All right, you guys, let's continue. And I put up another example of the substitution rule. So, what am I going to do with this? Well, I need to think about an inside function, right? So I kind of see something and then I see a product. I don't quite see a product, but if you want me to, I can rewrite this for you as a product by bringing this denominator back up, right, with a negative exponent. So now maybe you see a product, maybe you see an inside function as well. Maybe that looks better. So let's see. I'm gonna call, and again, these problems are all, it's not like I'm telling you, oh, does this work or not, and all of a sudden you can't do it. Yes, they are all about the substitution rule. So I'm going to call that inside quadratic polynomial by the u. Okay, so then what is the derivative of u? That's 2x minus 4 dx. Okay. Now I don't see a 2x minus 4, but I see an x minus 2. So how about this? Can I factor out, just so you could see it better, can I factor out the x minus 2 there? And there you can see it. It's a common 2 factor that was missing, yes. So how do I make that factor come up? Well, I'll put it in. If I put it in, what else do I have to do? Well, I have to take it back out. Then I have left myself no room. Then I could put it in front of the radical, by the way, the integral, by the way, but just so you won't freak out, I'll put it inside. Okay, so I multiply by 2 and I multiply by a half. That's a 1, right? So multiply, divide by it. It's kind of like, hey, you need a common denominator. Multiply top and bottom by the same value. You're not going to change anything, just the appearance. So it's the integral of 1/2. And let's see, what can I substitute? The 2 parentheses x minus 2 and the dx. The 2 parentheses x minus 2 and the dx are now called the what? Du. So I'm going to put a du in its place. Okay. What else do I see? I see this parentheses and a negative 1 exponent on top. So instead of all of this, yes, what do I write instead of x squared plus minus 5x plus 5? I'm going to write u, yes? And that u comes with a negative 1 exponent. That's it. Look at that. Okay, so that's just very simple. And now this is something I can easily find the antiderivative of. So I'll keep the 1/2. Who remembers what's the antiderivative of u to the negative 1? That was our special case. You can't increase it by 1 and divide by it because that'd be 0 over 0. So remember, that's the ln antiderivative, okay? And now let's just take it back. And remember to put absolute values. Resubstitute all this back. Oops, not the x, but plus k. Okay, you can take the derivative of this just fine and find out that it works. Okay, let's try one more. And then we'll go to definite integral. So find the integral of 3x to the 4th plus 4x to the 3rd, the whole thing to the power of 4 times x cubed plus x squared dx. So again, you might also be wondering, who should be your u? Should you call this quantity by u, or should you call this quantity by u? It's of course the one that's inside a chain rule, right? So it's the inside of a composition of 2 functions. That has to be your u. So I'm going to call this 3x to the 4th plus 4x to the 3rd by a u, right? Now, what is its derivative? It's going to be a 12x to the 3rd plus 12x squared, and then dx. Remember, we didn't want to write du over dx and then multiply it over. Saved one step. So, do I have something that looks like this? I see x to the 3rd. I see x squared. What is it that I don't see? I don't see the 12. But the good news is it's the same 12 that's in both, so I can factor it out. If this was 12 and this was 10, it wouldn't work, right? So, of course, we're making it work for you because you should be able to use the substitution rule. So, what is it? I needed an extra factor of 12. I multiply it, but I also have to divide by it. So I multiply by 1/12 and by 12. So nothing happened. So let's substitute it back. So I see the 1/12. What else do I see? This whole thing, we called it a u, right? This whole thing is called a u to the 4th times this whole 12 x cubed plus x squared dx is just called a what? A du, right? Boom. There you have it. No extra variables, just the u. So the antiderivative of that is 1/12 u to the 5th over 5 plus k. All right. I'm going to combine these. 1 over 12 times 1 over 5 is 1 over 60. Ugh, did I write 16? 1 over 60. And instead of u, I'm going to bring back what the u was. And what was u? This to the 5th plus k. So the point was to do what? To be able to evaluate or find this antiderivative, yes? To be able to drop this. And we did, because we knew how to find the antiderivative of this very simple function. And we found it. So this u is just a little aid to simplify this massive, massive looking thing into something very easy whose antiderivative we can find. And once we found it, well, we bring back the x's. The story was about x's and not u's. So I hope this helps. Okay, now let's try a couple definite integrals. I'm going to give you just one problem. And then the next one, I'll make it, or the next couple ones, we'll make it a story. So here it is. We want to find definite integrals using substitution. Okay. So how would this look like? Here it is. I want to find the integral from 1 to 2. So it's a definite integral of ln of x squared divided by x dx. That's tricky. So here it is. So I'm going to show you two different ways. In calculus, we're going to use the second method, maybe for now, but I think sometimes maybe it's just easier to just stick with what I'm going to show you first. Okay, so first things first, who should be the u? Do you see an inside function? In other words, a function that's wrapped on the inside of a different function. So usually, right, we have some kind of power rule, and we call whatever's on its inside, that's our inside function. So u, in this case, is ln x. Okay, that's whole ln x is being squared, so that's our inside function. What's the derivative of this function with respect to x? So du is what? The derivative of ln x is 1 over x. And don't forget the dx. Do you see a 1 over x in there? Sure enough. And if you don't, I can rewrite this for you. It's the integral from 1 to 2 of what? ln x squared times 1 over x, right? That's what it means to divide by x, to multiply by 1 over x dx, okay? So that's it. We didn't even have to bring in anything, multiply, divide by anything else. There it is. So substituting these, it's going to be what? U squared times 1 over x dx is just a du. Okay. I kind of left off those limits of integration a little bit because we are just concentrating on doing what? And again, not that I couldn't write it, but it's kind of like find that antiderivative first, right? Find that capital F function. So what's the antiderivative of u to the second? It's u to the 3rd over 3, yes? Plus my k except for we're not going to have a plus k. And I just keep not wanting to write those limits of integration yet. And I'll show you why. Because what is it? Now take this u back and do what? Change into ln of x. And then what do I do with this antiderivative? Once I found it all the way, I'm plugging in a 1 and a 2. Why is it that I did not want to put a 1 and a 2 here for you? Because I didn't want you to be tempted to plug in 1 and 2 in place of u. This 1 and 2 were numbers that depended on what? On x, not on u. Yes, so those are values to be substituted for x and not for u. Okay, so put this in your calculator. By the way, ln of 1 is 0, so 0 to the third over 3, that's a 0. ln of 2 is some kind of number. Whatever, 0.691, something like that. Cube it and then divide by 3, and you're going to get approximately 0.111. Now, that's it. So the point is, what I'm trying to do is, I'm trying to okay, take this problem aside. Yes, kind of a thing. Take this problem aside. Find its antiderivative first. Just concentrate on using the substitution rule as we just did to find that antiderivative. Once you found it and you plug the x back in, make sure that there's a second part of it, and that's to plug in the values. Now, what we're doing in calculus is following. We are changing the limits of integration. So I'm going to redo this problem with a different method. It's up to you which one you want to use. Okay, so the different way is this. We still need to use a substitution, right? So still, I'm not going to make it red. You already saw it. U is ln x. Du is 1 over x dx. Now, what you also want to do is you want to change your limits of integration with respect to u. So, what is u evaluated at 1? So, if you make x equal to 1, what is u at 1? In other words, ln of 1. ln of 1 is 0, right? We just talked about that. What is this new function evaluated at 2? ln of 2 is, what did I just say, 0.6913, something like that. Put that in your calculator. Okay, so, or just leave it as ln of 2. That's fine. Okay, don't even put in your calculator. So, when I make my substitution, I substitute everything in terms of u. These were limits of integration for x. The limits of integration for u have changed to what? The u at 1 turns into 0. The u at 2, u of 2 is ln of 2. Yeah, I'll leave it there. Okay. Then what? ln of x is u squared times the u. Now, when I find my antiderivatives, because I changed the limits of integration already, yes, there is no reason to go back to x. So I don't have to go back to x because these numbers are now about u. So what are the numbers going to be? ln of 2 to the third over 3 minus, plug in a 0, 0 to the third over 3. So is this the same exact thing we had before? ln of 2 to the third over 3 minus 0. Yes, that's the value of it here. Yes, so it's the same exact thing. So you can change the limits of integration, make it all about u, and then you don't even need to get back to x. Remember, a definite integral is a number at the end. Yes, so it's not something with x's, not something with u's, it's just a number. Okay, so one way or another, it's up to you. Make sure if you keep these limits of integration, the 1 and the 2, and you don't change it, that you go back to x's, right? They're to be replaced for x. If you changed your limits of integration to match your function u, that depends this way on x, then you don't need to go all the way back to x, right? Then you just substitute it in for u. That's it. So, we'll try 2 more. And these are going to be definite integrals. So here is one. I want you to find the integral from 0 to 9 of the cube root of 2x squared plus 1 x dx times x dx. Okay, so it looks like a product, yes. It's a composition of two functions, and I kind of-ish have the derivative of the inside function. So what's the inside function? Well, it's whatever is inside that cube root. So that should be our u. Great. What's du then? Du is going to be 4 times x dx, right? So I see the x dx. What am I missing? Oh, a 4. No problem. I'll put it and I'll take it right back. Okay, so let's substitute all of this. So I have the 1/4. I have the cube root of u. And the 4x dx is du. So now it's up to you. Again, it's a definite integral. What do you want to do? Do you want to leave it in terms of u's? Again, if you leave it, you need to change the limits of integration. So what's u when you make x 0? So when you plug in a 0 for x, you get a 1. And what's u if you make x 9? That's going to be 9 squared is 81. 162 plus 1 is 163. Okay, put it in your calculator. You actually, eventually, you still have to find these values, even if you put it in place of x's, or in terms of x's again. So these are your two new limits of integration, right? And now your story is all about u. There's no reason to get back to x. So what's the antiderivative of this? Is 1/4. This, by the way, is what? It's a u to the 1/3. So that's a u to the 4/3 divided by 4/3. Plug in a 1 and a 163 in it. I'm going to fix this a bit. To divide by 4/3 means to multiply by 3/4. So that's 3/16 u to the 4/3. Plug in a 1 and a 163. Okay. So it's going to be something that's 163 to the 4/3. It's not going to be a pretty number, but 1 to the 4/3, that's a 1. Put the whole thing in your calculator, and it sounds like you're going to come up to 166.76. Okay, so there's that. Okay. And let's just do one more. And here's a story. It says a worker can do something. At a rate of. So how about we make him install jet engines at a rate of, and remember what a rate of will mean, at a rate of, here it is, x times x squared plus 36 to the negative 1/2. And that's a rate, so obviously that means engines per hour. Okay, so how many engines will he install in the first 8 hours of work? Okay, so how many engines will he install in the first 8 hours of work? So again, there's your key word. This is a rate of. So I'm giving you the derivative, yes? And I'm asking you to find an accumulated amount. So within these hours. So that's simply a definite integral. First 8 hours is from 0 to 8 of x times x squared plus 36 to the negative 1/2 dx. Great. Now again, we're going to use the substitution rule because I see a product and definitely I see a composition of two functions. Okay, so here it is. What's the inside function? X squared plus 36. What's the derivative of this u? 2x dx. Don't forget the dx, right? It's a du over dx. Okay, do I see an x and a dx? Yes. Do I see a 2? No, I don't. Well, there, now I do. What else do I have to do? You can put it on the outside or on the inside. I just didn't leave myself room. But remember, what do you do with constants? You take them on the outside anyhow. Or again, if you don't want to be freaked out, fine. But that's really one of our rules. That what do we do with constant factors inside a derivative? We take them out and we, inside an antiderivative, or yeah, inside a derivative as well, we leave them, right? Take them out and then move on to the x part. So that's going to be an integral of 1/2. What do I write? Instead of 2x dx, 2x dx, that's a du. I'll write it at the back. What else do I have? I have the whole x squared plus 36, which is called u, to the negative 1/2. Okay. So, what else? Maybe we should change